So we've all dreamed of having some crazy high-tech tool like they do in the movies that helps you build something faster and easier. Like Spider-Man designing his new suit, or Iron Man building the Mark II. So we want a workbench that allows us to go from an idea to an actual prototype as quickly as they do in the movies. So we're gonna take a little inspiration from the Avengers, where Tony Stark rolls out this bad boy and starts designing Avengers Tower. And we want to bring this awesome engineering superpower to life. So let's get building.
We're calling this project the HoloMat, and it has 3 requirements. It has to roll up, it has to be a touchscreen, and it has to control all of our machines. So here's the plan. We're going to build a flexible touchscreen mat with a projection system that will display our custom interface. I think the hardest part is going to be the flexible touchscreen, so let's start there.
So the first layer is this sheet of rubber that we got to protect the workbench and to keep the HoloMat from sliding around. The second layer is this capacitive touch foil that plugs in via USB and tells you where you've touched. The third layer is the sheet of matte black vinyl that's gonna go on top and give us a nice finish that we can project on top of. Now let's get building. The capacitive touch foil comes with a layer of adhesive so it sticks right to our rubber. Next we add the vinyl, and that was the hardest part of this whole project. We really underestimated how hard it was to adhere the vinyl with no bubbles. We found using a straight edge and only doing sections at a time really helps. But we did not get it on the first go. This took several attempts, and peeling the vinyl off each time was really difficult. Once it's adhered, it's really stuck. Now we're just gonna use a razor and shave away the excess vinyl. We're hoping when this is all done, all 3 layers will be able to roll up just like in the movie. What you doing?
Just trying to get these bubbles out. It's not really working that well.
You try this?
I have not. Thank you.
Now that we've hit it with a hammer, let's make sure it still works by plugging it into a laptop. Yeah, it works. We created this 3D printed cover to hide all the electronics. We just threaded the cable through and then snapped it into the board, and we're good to go. That should hide everything in this small box and give us a cool, clean look. Now let's see if it rolls up like it does in the movies. And there we go. It rolls up nicely, and it should roll out all on its own. So the mat is done, and it came out great. Now, onto the projection system. And for that, we came up with 2 methods. We 3D printed this custom bracket to hang it on the ceiling, or for you guys at home, we came up with this stand to mount it on. For this project, we're gonna use the Raspberry Pi 5. It's basically a tiny computer that can fit in your hand. The Raspberry Pi has HDMI out, you can connect a keyboard, a mouse, even Bluetooth headphones, and it's got a 2.4 gigahertz processor. It even has USB ports, just like a normal computer. Now we just have to get the projector mounted on the ceiling. Luckily our studio has an unfinished ceiling to make this super easy, and we'll mount the Raspberry Pi just above it. Now we just have to load it with Raspberry Pi OS, and we'll start it right up. So now all we have to do is plug in our HoloMat over USB, and it should be touchscreen. So if we just touch and drag, we should have full control over the computer. Next, we need a cool, futuristic-looking software that allows us to create things and connect to the machines in our shop. So we're gonna get started on that.
For the software, we've been working for months on end developing a high-end futuristic HUD interface for the new HoloMat instance. So without further ado, this is the new HoloMat V3.
The software for the HoloMat was developed in React and JavaScript. This provides not only great visuals, but also a good user experience and makes it more efficient to run. As you can see, we've put a lot of effort into the visuals, providing the best user experience possible for the user. The bare minimum requirements to run the HoloMat is a Pi 5, but we recommend having a minor computer of any generation to power the HoloMat. App Inference has had a brand new rewrite, now providing you with this circular app carousel where your apps will be dynamically added as you create them. And creating apps is really easy. All you need is a singular JSX file to get started. We even provide you with a markdown file with instructions on how to develop new apps. The HoloMat will be continuously updated over time, providing new apps, features, and upgrades in the future. So stay tuned and let's send it back over to Concept Bytes.
So the software is done, and it looks super slick. Now, all we have to do is load it up on the HoloMat and try it out. All right, we got it loaded up. You think it's gonna work?
Probably not.
All right. Yo,
Looks good.
okay, that's sick. So the best part about the HoloMat is that it's not a screen, so we can actually work on top of it without damaging it. The HoloMat is great for designing. Let's say I want to make a pickleball paddle. I'll open up a 2D image, scale it to real life size, place my material, and then trace it and cut it out. So we did something really cool. For a more automated process, we sent this over to our laser cutter to actually cut out a pickleball paddle, all right from the HoloMat. Because the HoloMat is for life-size designing, we're sure to get the scale right on the first try. And here's the finished paddle. It's made out of plywood, we added a pink trim, and now it just needs a finished handle. One of the apps we made for the HoloMat is a drawing tool. It simply allows you to draw anything you want just by touching. The best part about the HoloMat is that you can export to any of our machines directly. So if we want to laser cut this on our Xtool, all we have to do is click export and send it over. And now we can laser cut a business card that says, "Hi Mom." This is the Xtool F1 Ultra and it's running in real time. This video is not sped up. The dual 20-watt fiber and IR laser are the first of its kind, and it allows for ultra-fast laser engraving. Huge shout out to Xtool. This machine is awesome. We use it all the time for rapid prototyping and anything we're making. We built plenty of apps to help with both 2D and 3D design, like our 3D viewer that allows you to view models, change the color, all before you send them over to your 3D printers to make. It's super fun to use, and spinning models around in 3D makes you feel just like Tony Stark.
Mine can actually do some good.
I think we nailed it with this design. But what if you want to design 3D models and actually create them on the HoloMat? Well, we made an app for that too. This is the 3D Model Creator app, and it allows you to create a model with just your voice. A raccoon in a party hat in a trash can. We were able to accomplish this Tony Stark style of building with a model called Hunyan 3D by Tencent. It takes an image and turns it into a 3D model. So the whole pipeline is speech to text, then text to image using DALL-E 3, then image to 3D model. So after we design something, we want the HoloMat to actually make it. So we're gonna get the HoloMat connected to our Bamboo Labs 3D printers and our Xtool laser cutter. So I just finished making the app that connects to your Bamboo printers. It's able to take G-code, view your print status, and even view a live stream. So check it out. So all you do is open up 3D printing, click launch, and here you can see we have a print running. It's got 563 minutes left. Here's a little thumbnail of the print. You can see the bed temperatures there. If we zoom out, we can see more. We got the nozzle temperature, the chamber temperatures, and we can click to view the live stream. So let's get this loaded up on the HoloMat. Okay, so we just loaded up the app and now we're launching it. And we can go over to the dashboard and you'll see the exact same page we saw before, but now it's on the HoloMat. I was even able to build an AMS monitor so you can check your filament levels. And here's the finished raccoon, modeled with only our voice. No Tony Stark project is complete without the integration of his AI Jarvis. And for that, we're using the OpenAI Real-Time API, which allows us to send audio packets and receive audio packets, cutting out any lag in the conversation. So all we have to do is click. Hey Jarvis, let's use a gold titanium alloy.
A gold titanium alloy could offer a unique combination of properties. Gold is known for its excellent corrosion resistance and attractive appearance, while titanium is renowned for its high strength to weight ratio and durability. The alloy could be particularly useful in applications where both aesthetic appeal and mechanical strength are important. How do you plan to use the alloy?
It's for a suit I'm building.
Using a gold titanium alloy for a suit sounds innovative and potentially groundbreaking. especially if you're thinking about combining the material's durability and aesthetic qualities. The alloy could provide both lightweight strength and a distinctive look, which might be particularly beneficial for advanced, high-performance wearables or protective gear. Depending on your requirements, you might also want to consider the alloy's flexibility and how it could enhance the suit's functionality.
Now that we've finished this awesome engineering tool, we want to build some projects with it.
So let us know in the comments what we should make with it.
And if you want to build the HoloMat or Jarvis or any cool engineering projects, check out our Patreon.
We're new to YouTube, and it helps us make your ideas come to life.
Thanks for watching.